In this lesson, we'll be determining an equation of a parabolic function given the two x-intercepts and a point. So, suppose we are given 2 points. Let's say we are given the points -2 and 0. These are the x-intercepts. How do you see the x-intercept? Because they have a y value of 0. Okay, and we have the x-intercepts -2 and 0, -3, 0, and we're given a point. Let's say this point is given as 0 and 6. Okay, so how are we going to do this? The formula which we use is given as y is equal to a multiplied by x minus r1 multiplied by x minus r2. Okay, so r1 and r2 here stands for the two x-intercepts. So we're going to do it in this way. First of all, you start by substituting the value of r1 and r2. These are given from the two x-intercepts. To notice if something is an x-intercept or not, as long as it has a y value of 0, because we said the coordinates are written as x is to y, x is to y. And because this one has an x-intercept, it has a y-intercept of 0, it means it's a x-intercept. Okay, we said that for an x-intercept, you let x be equal to 0. For an x-intercept, you let y be equal to 0. Sorry. So, if x is -2, y is 0. This means it's an x-intercept. If x is -3, y is 0. It means it's an x-intercept again. But let's look at this one. 0 and 6. If y is 6, x is 0. This means that this is the y-intercept. The y-intercept is 6. Okay, so we're going to start by plugging the two x-intercepts on the place of r1 and r2. We're going to say that y is equal to a multiplied by x minus, you plug the x-intercept. The first x-intercept is -2. So we're going to plug a -2 here. And then we're going to say x minus, again we're going to plug -3 is the second x-intercept. So we're going to say that y is equal to a multiplied by x. What is negative times -2? That gives us +2. Multiplied by x, negative times -3, that gives us +3. And we're going to say that y is equal to a multiplied by. So here we're going to use the method of while. First, outer, inner, last. What we mean there is that it's x times x, it's x times 3, it's 2 times x, and it's 2 times 3. So x times x is given as x squared. And x times 3 is given as 3x. 2 times x is given as 2x. And 2 times 3 is given as 6. So I'm going to say that y is equal to a multiplied by x squared plus 3x plus 2x, that is 5x, plus 6. And now we're going to solve for the value of a. Remember, to solve for the value of a, we're going to use a point which is given. To find firstly, we used the x-intercepts. Now we're going to use a point. You can't use an x-intercept again. But now we're going to use the point 0 and 6. So we're going to say that where we see y, this is x is to y. So where we see x, we put 0. Where we see y, we put 6. So we're going to say that 6 is equal to a multiplied by, where we see x, we're going to say it's 0 squared plus 5 times 0 plus 6. And the bracket is like this. So here we have 6 is equal to a multiplied by 0 squared plus 5 times 0 plus 6. That gives us 6. So we have 6 is equal to 6a. So we're going to divide both sides by 6. We divide both sides by 6 and we divide both sides by 6. 6 cancels 6, 6 cancels 6, and then our a is equal to 1. So we're going to go back to the formula here. We're going to go back to this step and plug in the value of a to get the final equation. So we're going to say that y is equal to a, we're just going to say 1 multiplied by x squared plus 5x plus 6. space there was insufficient. So we know that anything multiplied by 1 remains unchanged. So at the end, we can say that our equation is given as y is equal to x squared plus 5x plus 6. And this is how we can determine an equation of a parabolic function. Given the two x-intercepts and a point, the point might not be a y-intercept, might be any point. But first of all, check for the x-intercepts. R1 and R2 stands for the x-intercepts. This one, R1 and R2, stands for the x-intercept. So the first x-intercept is -2, and the other one is -3. That's why we plugged -2 here, and here we plugged -3. And we are given another point. After coming to this step, we're going to substitute this point that we never used to get the value of a. Then after on calculating the value of a, we are now going to return it back into this expression here, or this equation, to find the final equation. And at the end, we have a defining equation which determines the quadratic equation. I hope it is clear. Thank you for watching.